Hello friends. So today I'm going to discuss about the Boolean expressions in various form, right? So Boolean expression means the logical expression, whatever gate we are using. Suppose AND gate or gate NAND gate we are using. So we can suppose you have a one circuit, one system. In this system, you have multiple AND gates, NOR gates, and AND gates, right? So if you want to get final output from those gates, you have to write in a one expression, that is the Boolean expression, right? So Boolean expression can be written as a different forms, right? One is the SOP form, another is the POS form. Okay, so SOP form. So first I am going to discuss SOP, that is sum of product. Okay, so when we will use the SOP form. Okay, so POS I will discuss later now, right? So SOP. So before going to the SOP means sum of product. So suppose you have one expression, right? So A, B, C plus A, B prime, C prime. Right now we can see product. Product means the multiplication of A, B, C, and multiplication of A prime, B prime, C, and sum. This is the summation. So summation of the products, right? This is the SOP, right? So now, so related to SOP, I will discuss something now. Okay. So first we'll tell about the related to SOP, what is the truth table. Okay. So normally, suppose I'm considering the three variables, right? So three input variables, if it's there, so you have the total 2 to the power 3, 8 combinations. Okay. So for first I'm writing 8 combinations truth table. Okay. So A, B, C. So here I'm writing 8 combinations truth table. Okay. Now output. Okay, so based on the application, or based on, suppose this is a one SOP, so based on this expression, so whatever output we are getting, so output we can write in a expression form, that is a Boolean expression, or this expression may be we can write as a sum of product. Okay, so I am writing some output. So we don't know what are the outputs now, right? I have written truth tables. So how can you represent the output? Okay. So after that we will, so if one is there, there will be output at the Y section. If one is there, so that means some output we will get. And if zero is there, you are not getting any output. That is false condition. Before writing some output for a specific application, so I can write the output that y in a various form for 8 combinations, right? So here you can see 0 0 0. So 0 0 0, so if 0 is there, that means the you can write as a 0 means, suppose 0 means A prime, 1 means A. Okay, in this way I have to write, right? So you are adding these three things, means you have to do multiplication. Okay, so for corresponding 0 0 0, what will be my Y? Okay, A prime, B prime, C prime. So if any application, if this term is not there, then it will be 0. Okay, if any application this term is not there, so suppose here 0 means the A prime, B prime, C prime is 0. Okay, so here, and 0 0 0 0 0 means 0. Okay, so that is also I can write as a m0, small m0, right? So these are called, this all the combinations are called mean terms. Okay, representation of the output in SOP form is called as a mean term. Representation output in normal truth table, these are known as a mean terms. Okay, if we use the mean terms, you will get the SOP. Okay, for getting the SOP, you normally use the output as a mean term. For getting the SOP, for getting such kind of the expression, multiplication then addition. For getting such kind of the application, okay. So normally we can represent output as a mean terms, right? So that means 0 0 0, A prime, B prime, C prime, M naught. So it depends on the application. In some application you will get M0 as a 0, or in some application you will get M0 as a 1, right? So here 0 0 1. So 0 means A prime, B prime, C. C, it is 1, right? It is 0, it is 1. 1 means it is small m1. Okay. So here it is A prime, B, C, M2. Okay, A prime, B, C, M3. A, B prime, C prime, M4. A, B prime, C, M5. A, B, C prime and 6. So A, B, C and 7. So for getting the SOP expression, so these are the representation of the output. Okay, M0, M1, M2, M3, M4 like this way. Suppose uh, you have one question. Okay. Okay. So the question is like this. So for if you want to write output for a, some problem, okay, how can you write the output in min terms? Okay. So this is the f a b c. That means I have an output which is depends on a b c, three variables, right? And what are my outputs, right? Summation min terms. These min terms I can write as a summation small m 0, 4, 6, 7. What does it mean? That means for M0, M4, M6, M7, I have output 1. Okay. So for this condition, M0, M4, M6, M7, my output is 1. Okay. And all other combinations, rest of M1, M2, M3, M4, so M1, M2, M3, M5. For these 4 combinations, I don't have output. Okay. So suppose you have one expression, that means from this expression I have to understand these are the min terms. Okay, not max term or other thing. So these are the min terms. So from min terms, whatever expression I will write, so this expression will be associated with the sum of product. Okay. So here, so suppose you have expression. If you have a one question, f within bracket a comma b comma c, summation m 0, 4, 6, 7. Okay. That means I have outputs in, if you write the truth table, I have output in M0, M4, M6, M7. Okay. Now, so M0 also can be write as A prime, B prime, C prime. So suppose you have this question, if you want to get logical expression, how can you get? So M0 is A prime, B prime, C prime. Okay. M4 is this one, A, B prime, C prime. Okay. A, B, C prime and A, B, C. Okay. So, but this is not a final expression. You can minimize the expression. Okay. So, for suppose if you want to design the diagram, you need a simple diagram, not complex diagram, or you need a diagram which consists of only less number of gates. Okay. Suppose the question is like that, you have this question. That means I have the expression in min terms. Okay. So this M0, M4, M6, M7 means so I have logical one output for M0, M4, M6, M7. And if you write this thing in Boolean expression form, you can write this way. So for that you have to remember this entire table. Okay, this is the truth table for SOP expression. Okay, these are the min terms, right? So these min terms, so whatever min terms are available in this function, corresponding to this min term, I am writing the expression. So from this expression, you can minimize the expression, you can draw the logical diagram. Okay, so I am showing you the minimize expression. Okay, so now here you can see, so ABC prime and ABC. If you take AB common from C plus C prime, so C plus C prime is 1. Okay, so you will get AB. Okay, you will get AB from last two terms, right? So I am checking this one. Now if you take B prime C prime common from these two, you can get A plus A prime. Okay, if you take B prime C prime common, we will get A plus A prime. So A plus A prime is also 1. So that means B prime plus C prime. So you final F is equal. This is the minimized version. B prime plus C prime plus AB. Okay, so if you know this function, you can draw the logical diagram. Okay, right. So this is A, B. Here you will get AB, right? So I am taking B prime, C prime. Here it is B prime, C prime. Now I am doing the OR function. So this is the final logical diagram. Okay. So A prime, B prime, AND gate is required for B prime, C prime, and one more AND gate is required for getting B prime and C prime. So I need two NOT gates, right? I think so. For addition, I need a one OR gate. Okay. So this is about the min term. Okay. So suppose you have this question. So suppose you have In question it is mentioned, the min terms are mentioned. So from the min terms you can get the expression, and you can get the minimized expression, you can draw the circuit. Okay. Opposite, another kind of the problem, this is called the analysis, design. Okay, design, right? This is associated with the design, right? Because I have function, so from function I am getting output, and corresponding to output I am drawing the function. So associated with the SOP you can get it another kind of the expression. Okay, suppose you have this one diagram. Okay, so you have one diagram. So from this diagram, you have to analyze all the things. Okay, from this diagram, you have to write the truth table. How can you write from the truth table? Okay, so how can you write the truth table? This is associated with SOP only. Okay, how can you find that this is associated with SOP? So for SOP, first will be AND gate, and then at the final section you will have the OR gate for case of the SOP, because product then addition. Okay, so if you see the circuit, you can tell that this is associated with the SOP only. Okay, so I am writing the final expression. Okay, A B plus B C. Okay, now so this is called the, this is also SOP, but this is not the standard SOP. This is called conical SOP. Why it is conical SOP? Now you can see here three variables are there, but of each product you have the two variables. Here you have AB and here you have BC. Okay, here C is missing, here A is missing. So from this expression you cannot write down the truth table. Okay, you cannot write down the truth table. So I have to convert this conical SOP to standard SOP. Okay, so here suppose here C is missing, so I am writing C plus C prime. Okay, here A is missing, so I am writing A plus A prime. Okay, now A, B, C, A, B, C prime, again A, B, C and A prime, B, C. So these two are same, so you can consider it as a one term. Okay, if both are same, so what is the property? A plus A is equal to A. Okay, so by using this property, I am writing here. So only three terms. Okay, ABC prime and A prime BC. Okay, now we have to write the truth table and this function in terms of meter. Okay, now if I have the this truth table, now we can see that ABC, where I can find ABC, this is ABC. Where ABC prime is here only. Where A prime BC, it is A prime BC. That means if you want to write the truth table for Y, that means here it is 0, in this condition it is 1, here it is 0, in this condition it is 1. For M6, M7, M2 are available. Okay, and if you want to write the function as a summation form, so what are my M available? 1, M2, M6, M7, 2, 6, 7. So if you have the circuit, you can write the expression from the circuit, then you can convert the circuit into the standard SOP form. This is the standard SOP. So if you remember this truth table, from by using this truth table you can write the final output, okay, for the particular truth table, and also you can write the expression in terms of min term. Okay, now this is about the SOP. Now come to the POC. Okay, now come to the POC. So for POC also I am considering three variables. POS means product of sum. Okay, product of sum, suppose we have one expression. Okay, so suppose sum, first I am doing sum, here also I am doing sum, after that we are doing the product. So such kind of the expression is associated with the product of sum. Okay, so if we have this expression, so if you want to write the truth table for this expression, so for this you have to consider the max term. Okay, if we have the SOP expression, for this if we want to write the truth table, you should consider the min terms. But if you have the product of sum, so we have one circuit, so from one circuit you are getting such expression, product of sum. So for that you have to consider the max term. So what will be the truth table for max term, that I am writing here first. Okay, So same truth table you have to write for three variables. Okay, so max term will be considered as a capital M, M1, M2, M3, M4, M5, M6, M, sorry, 0, 1, 2, 2, 3, 4, 5, 6, and 7. Okay. Now, suppose the opposite this thing I am doing. Okay. Now here you can see. So these are the max term. Okay. You can write as a max term, or if you want to write the max term as an expression. So here for max term, a means 1, a prime means 0. Okay, if you want to add these three terms, if you want to include these three terms, you have to put a add. Okay, so capital M0 means a plus b plus c. 0 means a. Okay, if you want to include all other two terms, you have to put a plus. Okay, so here a plus b plus c prime. Okay, a plus b prime c. A plus, okay, in opposite. A means, sorry, here it is a means 0, a prime is 1. Okay, this way I am writing. A means 0, a prime means 1, right? So here a plus b prime, c prime. Okay, so 1 means b prime, c prime. So here also a prime plus b c. Okay, here also a prime plus b c prime. Okay, a prime plus b prime plus c. Okay, a prime plus b prime plus c prime. That means instead of dot for a mean term, so instead of plus dot is there. For mean term, instead of a prime is there. So for mean max term, a prime is 1, a is 0. Okay, for mean term, a prime is 0, a is 1. Okay, plus means dot. Okay, dot, right? For this is the mean term. Okay, so opposite phenomena here. Now, okay, now I am minimizing. So I have expression. So I have to, again you can see for case of the POS also. So in these two sum, okay, in these two sum you can see this C is absent, here A is absent. So I have to convert, this is the conical POS. Okay, I have to convert this is a standard POS. Okay, so A plus B plus C dot C prime. Okay, b plus c prime plus a dot a prime. Okay, because c dot c prime is 0, a dot a prime is 0. That's why I'm putting here. Okay, now here I can write a plus b plus c, a plus b plus c prime. Okay, b plus c prime plus a, b plus c prime plus a prime. Okay, now I have to write the truth table. Okay, you have the final standard SOP. I have now to write the truth table. Okay, now you can see a plus b plus c. Where it is? Here. Okay, now a plus b plus c prime. A plus b, here it is. Okay, now a plus b plus c prime. So both are same. Okay, both are same. So only one term I will consider. Now here a prime b plus c prime. A prime b plus c prime here. Right? So I have the logic 1 in these three combinations. Here for M0 I have logic 1, for M3 I have logic 1, and for M5 I have logic, sorry, for M6 I have logic 1. Okay, so if you want to write the truth table, you have to put 1 1 in this M0 and M1 condition. Here also you have to put 1 for M5 combination, right? And here it is 0. So this is the output for truth table. Now if you want to write the expression, how can you write? So here it will be capital M. Okay, because these are the M, right? Which M's are present here? M0, M1 and M5. Okay, 0, 1 and 5. Okay, so this is the max term form. Okay, so you have the one expression in POS form. So POS form you have to convert into the standard POS form by considering this formula. And if you have the standard POS, you can write the truth table. From the truth table you can write the output as in the form of the max term. Okay, now again the opposite phenomena, if it is there. Okay, suppose one question is like that. You have capital M 2, 3, 4. Okay, 2, 3, 4. right? So what you have to do? To capital M 2, 3, 4. That means these are associated with the product of sum. Capital M means this is associated with the product of sum. Okay. That means M2, M3, M4. That means it is M3, M2, M3, M4. So in these three conditions, my output is 1. Okay. This is your truth table. This is your final truth table. So in this M2, M3, M4, for this condition my output is 1, for other condition my output is 0. Okay. Now we want to get the final expression for drawing the circuit. Okay. What will be the expression? So M2 means this one, right? A plus B prime plus C. M3 means this one. A plus B prime plus C prime. Okay. And M4 means A prime plus B plus C. Okay. So M2, M3, M4 I have written M2, M3, A plus B prime plus C. Here it is A plus B prime plus C prime. Okay. Here it is A prime plus B, C. Okay. Now you can see A plus B prime C into A plus B prime C prime. That means suppose this is entire considered as a one term. Suppose X plus C. Okay. And X plus C prime. Okay. It will be like this way. X plus C dot C prime. Okay. This is the Boolean properties. X plus C dot C prime. Okay. So here you can write as A plus B prime plus C dot C prime. Okay. C dot C prime is 0. Okay. Here I am writing A plus B plus C. Okay. So, okay. So C dot C prime is 0. Here it is A plus B prime. It is A prime plus B plus C. Okay. Now again if you want to multiply A dot A prime. Okay. A B A C. Okay. B prime A prime B B prime plus B prime C. So this will also 0. This will also 0. What is my final expression? AB plus AC plus A prime B prime plus B prime C. So this is my final expression. Okay, right? So this is about the POS. So if you have the function, how can you write the final expression? Okay, how can you write the circuit? Okay, or if you have the final expression, how can you write the truth table for POS? Okay, so next class I will discuss about the K-map. So what is the K-map? What is the importance of K-map? This I will discuss on the next class. Okay, thank you and kindly like, share and subscribe my channel.